So let's take that a step farther. MS13 inside here. How do we relate those two and get those two to actually...
And for this, we use what's called the chain
You do this.
rule.
This is a 2-hour class where we're learning, and you're gonna just, this guy's flaming sunshine out there. You're not gonna be able to help it. I need you to be able to do this with me, talking about what relation these had to Coke, what they had to medicine, what they had relationships to military standards, what they had relationships to at the causal level, brother. This is a price tag on your ass about these numbers banging around in here.
So you'll notice we're only ever sticking to the y1 coordinate, but we sum over the x2 coordinates. Because
like
remember I said that in order to identify the y1 coordinate, you need to know all of the other x
battery in your cell phone, all that. Because you take it out of the wall.
This can be summarized as d phi by dy, and now I'm going to call this dyn because it could be any, it could be 1 or 2 in my two-dimensional
I don't mind.
system.
It's like, but you know, like I said, you get political activists out there doing some things for
of d phi by dxm.
Great where it was supposed to be.
dxm.
If you didn't factor in 1/2 on the other end of those, this tech curve will burn stuff down.
Just look at this and compare it to this. What I've done is I've put
this
the general
string
value
theory of
n
electron positions in
y.
system,
Here
trying
I
to
just had
mute,
y1,
cut
but
down
it
on
could
the
have
air
been y2.
turbulence to straighten
You
it
have to
off
pick
on the
which one
pipes
you
to
want.
100%,
It's either
600
1 or
yards,
it's
800
2.
million of them,
But m is a summation
800,000
term.
of them a
You
second
sum
down the
over
pipes
m.
to get the
When
ratio
m is
right.
1, you get that term. When m is 2, you get that term.
You know what it is. Just takes a
This
lot
is
longer
going to
over
be
there.
equation number 2, and I'll put a box around that as well.
And it'd be hard to fight that box. It could be an open
But let me
border
just
with no
repeat and
fences.
emphasize, n is the value you choose. It's either
Look at
y1
breaking God over there,
or
man.
it's
You want to
y2.
get sucked into
You
that,
make
and
the
if
choice.
everything made out of metal,
But m is a
asshole,
summation
elbows
term. You
flying
have to sum
around.
over all the values of x just to get one of the values with respect to y. Now I want to introduce you to the concept of tensors. We mentioned that when we looked at the Einstein field equations. There were several tensors. What is a tensor? Well, let me start off by talking about a scalar. A scalar is something that has magnitude but no direction. Temperature
You
would be
are,
a good example
in
of
fact,
a
a ball.
scalar. It just
An electron
has a
inside
value.
here that helps you deal with the fear and anxiety of doing that number. Some people who squared that away.
A scalar is what's called a tensor.
It's a great way to do it too, and you can go deep without having to worry about, oh, is that the factor I needed to carry inside here about? No, you didn't. You didn't need to hang up, slow down, fucking deal with it, put an imaginary number on there, pack it through, and then if it's true,
the angle to one of the axes, in this case to the x-axis. And a vector is described as a tensor of rank 1. And how does a vector transform? Well, we can use equation 1 that we derived earlier, and which is showing on the screen, so you recognize it, and we just make a slight adjustment to it, so that instead of d phi and dx, we replace it by the vectors themselves. So we would simply say that the vector in the y frame of reference and with the coordinate n, which
everybody
we
wants
choose,
it to be something different anyways.
is
It winds
equal
up being
to
a
the
prison
sum
system, a college
over
model, a
m,
boot camp,
where m is now the summation
a business
term
model, an application for a
of
business model, the atom most, cracking the damn atom.
dyn
This cowboy,
over
look at him.
dx
I gotta figure out v, y, mu for you. Wow,
times the
limitless
vector in
infinities on
the
it.
x frame of reference,
Yep.
m. So that is the way in which we, and I shall call that
Okay.
equation number 3. That's the way vectors
I'm not going to give you too
transform.
much bullshit in my class about what you wanted this to be. I threw it up there, all you had to do was pack the stone mill into it. Really, you gave me something close enough where any of those forms were relative. If it needed some tightening off, or you need some burrs around those edges because you didn't notice the next manufacturing step in that, then I'm just going to help you dust that off real quick. It takes down a lot of the time than me to redo all that for you in that box.
Coordinate
and at that point in time, the matrix, the Schrodinger multi-world circumstance
that we will be
V,
interested
Y,
in
N.
are tensors of rank 2.
Now,
And
it
what
does
tensor
follow
rank
a
2
dark
is
web kind
a
of
combination of
crypto
vectors
on causal.
where there
It can't
is
be
a
the same
fixed
thing.
relationship between
You're
the two.
working that equation too hard.
So let's
You
just
need
think
some way to
of
stretch it out.
some
There's
system
a
which
ratio
has a
on
combination
how
of
much
vectors.
I can
Let's
pack
take
into
a very
one step
simple
at the
one.
saw.
Let's
And
put a
so
block on the
YF
floor,
over X equals
and we're going to apply a force
YF
to
over
it
X. I'm
in order to
actions
move the
those
block a
sets.
certain distance.
And that helps
X
me get
in this
some working
direction.
joules out of there. I could turn that
And
into
the work done,
voltage. I could turn that into the saw
will be the
crankcase
force times the distance.
on what that needed to do. But
But of
from the
course we can't
first
just
step
take
of
the
what that
force,
is,
we have
nobody's
to
going to
take
get that
the
because you're not. One, you
component
don't
of the
want them
force
to jump right
that
into
is
flaming
moving
Don's graph and
in the direction
calculator,
we
tool
want to
shed
go.
over there, L
So if
brackets
that
right all
angle
over the
is
place for
alpha,
lambda on time
then
checks for
the
erratic calc,
component
and it's
of
all
the
squared
force
away, would you?
acting in the direction of movement is F cosine alpha.
It's not done. You'd want to do that for them.
So the
If
work
it comes
done
off
will be
on top about what that
component
is
of the
later,
force that's
I
in the
mean, you still
direction
need
we
to be
want
useful
to
in this
move
job. Depends.
times
It
the distance
depends.
we travel. And you can think of F and X as being vectors. X has a magnitude and a direction. The direction is in the
It
X
wouldn't have a
direction.
damn thing to do with that.
F has
that
a
terminal
component that
fuse
has a
box, would it, John?
magnitude and a direction. The component, at least, of force in the X direction. It has
The number was
magnitude and
good, but I
direction.
caught an alpha
So we've got
variable
essentially
inside of here.
something
I
which
caught a
combines
beta variable
two
inside of here.
vectors.
I caught a alpha
Now,
that was playing
the question
beta.
is, suppose the force is in that direction. Then the angle alpha will be 90 degrees. And the cosine
It helps me
of
figure
alpha
out old
is
models
0.
and where this one's graphing
And therefore the
cyclically,
work done
because
will
that's
be
going to be
0
this cube
because of
being
course
pushed by
the block
friction
won't move. If you're pushing down
on a
the
flat
block,
surface, but
you're
it is
not
an
going to
angle.
get it to move
is.
in
You
the
can't let
X
these
direction.
guys fuck with your
And
facial
here's the
equation when
thing,
I need you to do that.
that
And
it
the
doesn't matter
hillside where
what
trees are
frame of
growing, these are
reference
the
you
roots
apply
dug into there,
to
get a
this
chainsaw.
system. Whatever frame of reference you apply, that block will not move. The value of the work done will be 0 in all frames of reference. And that's
And
the
if
value
I
of a
can
tensor.
catch you in
A
that box.
tensor is the relationship between two vectors. And if the relationship, if the tensor has a value of 0 in one frame of reference, it must have a value of 0.
Usually the numbers play
all
out the same.
frames
Why
of
would they get
reference.
so
If
far
that
out
block
of
doesn't
Fermilab
move,
at those speeds
it
for
doesn't
polar
move.
cells where I
It
can't
doesn't
just track
matter
a
what
photon,
frame
I
of
just need
reference
it
you
to
apply
be
to observe
in the
it,
pipes.
it doesn't move.
They keep clocking
Tensors, therefore, are relationships between
Your Honor,
fixed
I'm not
relationships
supposed to
between
know
two
what they do with
vectors
their home life. If
in
that come
such
up
a
at
way
the
that if
lodge,
that
that's
relationship
one
equals
fucking
0
thing, but
in
at
one
that
frame
point in
of
time,
reference,
you know
it
what
is
this
0 in all
is.
frames of reference. And that is why tensors are so important in Einstein's
I don't have a logic,
field
build one.
equations.
Logic.
So let's consider a combination of vectors. Doesn't matter what it is for these purposes. We're going to take vector A,
Good.
and we're going to take the nth coordinate of that vector. Remember, there are dimensions in space. I am actually using only 2 dimensions for this simplistic analysis, so m is either 1 or 2. You choose which one you want it to be. And we take another vector b, and we'll take the nth coordinate. That can be 1 or 2, you choose.
It was me. Oh,
And we say that the combination of the two becomes a tensor of
you already broke the
rank
rules.
2,
You broke the world.
which we
This
indicate
needs
by
to be a Z
saying
if you're going to do that.
that it has those 2
You
coordinates.
started with this.
M, or 2 indices, m and n, equals the vector A.
So you're too deep.
with
You'd
the,
read that this way,
coordinate
but you need the math to
dimension
understand
M
that actually
and
happened this way. And
coordinate
so what
vector
happens is
B
we're using time
with
cyclical
the nth
models,
dimension.
MNs, multiple sets
So
of those
obviously,
numbers where
if
they
there
indicate
are,
the same
if I'm
number
talking about
but
two-dimensional
over 2
space
different
where m
times
can be either 1
in
or
singlet
2,
states.
and
All
n can
this
be
work
1 or
I just
2,
packed together for the
then
Sharps
T,
report
M, N,
that
there
plays
can be
into the
4
physics of the universe.
versions
N1
of that
half,
tensor,
R, G,
where
1
m
half.
and n each have values 1 and 2.
That
If you've got 3 dimensions of space, m and
Well,
n
thanks.
can each have values 1 to 3, and so TMN has 9 different versions. If there are 4 dimensions of space-time, 1 time, 3 dimensions, TMN will have 16
I'm not living
values.
on Hacksaw Ridge right at the moment.
Well, now I'm going to use equation 3 that we derived earlier and which should be showing on the screen. to
Why would
take
Major be mad at me
the
if it's an
vectors
AR-15
A
and Heartbreak
and
Ridge?
B. So we're going to take AM
Here's my
in
class.
the Y
This is
frame
how I
of
break this down.
reference.
I'm sure they'd love me to
and
just sit down,
BN
take
in the
notes,
Y
write
frame
this
of
down
reference.
verbatim, word for word.
And
But
we're
when
going
I
to
was
try and
catching
see
with
what
that
they
later, it's
are
like,
in the
tweak
X
that a
frame
little
of
bit.
reference
You
using
did it, yeah.
equation
You
3.
did it.
Well, you can see that we've just got to replace V in equation 3
Because it makes it easy.
by A
N,
and
P,
then B.
problem,
So let's
complete.
do A first of all. We need a sum term. I can't use M anymore because that's already been used
You
here, so
definitely
I'll
did.
just
'Cause I got
introduce
here
a
about,
value
remember
R.
when
Remember, this is a
this.
summation term. It's called a dummy variable. It doesn't matter what you put. And that's going to be dym
Palm touching
by
click, click.
dx r times A in the X frame of reference, R. That does the vector A. And now we need to do the vector B in the X frame of reference, which again from equation 3 comes, I now need another summation term. Let's call it S.
See, I can take a
that's
landscaper's
gonna be
map too
dy
for a person's
N
house from a
by
$300 bill
dx
to make enough
S
money to get me through a few
times
days,
B
and I understand it's the
in
field
the X
kit.
frame of reference.
The landscaper's
S.
map when that thing is done.
So you sum over the R terms and you sum over the S terms,
Really?
but M and N are chosen. They're the values you happen to choose for this particular
It's a
equation.
house right here.
Well, let's
The
look and see
landscape
what
is
this
that.
reduces to. Firstly, AMBN, well, that's just the tensor TMN in the Y frame of
First
reference.
it's the
because that's
overhead
what
on
we
cutting
selected here.
grass, then you're doing some
And that is going to
hardscape
be
out
equal
front,
to
and then you're moving in.
the sum
Taking over.
over R
Moving
and
fridges
S.
around, planning
That's not quite the
timelines
right way
around.
to
It's
do
a real
it.
hard
But essentially,
job, man.
you've got
That's
two
fucking...
sum terms here, which I'm just going to simplify here. Multiplied by dym by dxr, and then you've got a dyn dxs.
If the cheat sheet for the
Times
periodic table, if they call it the world's
AXR,
greatest cheat sheet, you hide it with a matrix, you hit it with a
that's that
standard
term,
model,
and that term.
you run the chemistry behind this,
But
and
what is
bonds
this?
and
Well,
sets
if you
of
look at
triple
this
points.
term up here, you'll see
Sets of
that it's
triple
just
points.
another tensor. In this case, it's the tensor in the X frame of reference, but its indices are R and S.
But they're singlet
And
states.
that I'm going to call equation 4.
You'd have to. NP,
And
forbidden
I'll put
order.
a block around that because we may need that in the future.
They do. In the way that elements decay.
And that is
heat
called,
death will take
it
the
gets a
sun one
technical
day.
term, it's called the contravariant transformation. It's the transformation from the Y frame of reference to the X frame of reference for tensors.
Can make a code differentially
There is an
C4, but it
equivalent
was from me.
form
And
of
now I've
tensor
been running that
transformation
set
that is
forever.
called the covariant transformation, where the indices, which instead of being upstairs, go downstairs, but then the dy by dx terms are changed into dx by dy terms.
I let him
So
do
let
my
me
math,
just
and he seems
write that
pretty
out.
pissed right
You
now
get
about
the
you. I don't
T,
know if that plays
and
well.
now it's in the Y frame of reference, but the M and N go downstairs. So I'll put the M and N down here, and to make it clear, I'll put Y in brackets. So
Once
T,
you
M,
understand
and
that
N
statement
in
when
the
you
Y
say
frame
stuff
of
like that about
reference
time dilation
are
going
equal
back.
to, again, you've got this summation term over R and S. And now these two terms just go
Somebody
upside
else's
down.
house. Why were you in my fridge? Simplify.
dxr by dym, dxs by dyn, just inverting these terms here. And then the tensor term, again, goes downstairs, but it's in the X frame of reference.
Good here? I got a class for you.
And that is called the covariant transformation. I'm going to call that equation number 5.
Just in case.
So this is called the
It's one of those
contravariant.
dopey bastards
This
up
is
top
called
forget
the
who they are. I'll
covariant.
drag them down.
Contravariant have the indices upstairs. Covariant have the indices downstairs. Contravariant have dy by dx terms. Covariant have dx by dy terms. And it is actually the covariant form of transformation that is going to be of interest to us.
It's a long one.
Now I want to do a little bit of manipulation with something as basic as Pythagoras.